and cubes of monomials. Okay, so squares and cubes of monomials. I'm also going to touch on the square roots and cube roots of monomials. So this is basically just a revision of what you did earlier in the year, but let's have a look at some examples. So I'm going to go straight into examples so that we don't reteach, but I believe that you learn better through examples. So let's do the first one. The first one, if I give you 4a cubed to the power of 2, okay, and I say to you, simplify. All right, so simplify with these ones, you need to remember your exponential laws. Okay, so the exponential laws that you need to remember is basically if I've got a to the power of n times a to the power of m, then I'm going to have a n plus m. I need to remember if I've got a n and then to another power, I have to multiply. Okay, if I've got a times b in a bracket and I've got to the power of n, I can give that exponent to both of those. All right. I also need to remember if I've got a n over a m, that I minus my exponents. And there's a couple of more, but we'll just stick with those for now. So if I go back to this example over here, if I look here, how I'm going to start this question is I need to get rid of my exponents first. Now I've got something in the bracket to another power, so to the power of 2. So what I'm going to do according to my rules, I know that this power is going to go to each product. So the squared is going to go to the 4 and the squared is going to go to the a cubed. So 4 to the power of 2, and then a, I've got 3 and then to the power of 2. So I'm going to look at this exponential law where if I've got a power to another power, I need to multiply the powers. So 3 times 2 is going to give me 6. Now I know what 4 squared is. That is 16. So I've got 16a to the power of 6. Let's do another example. So we can say example 2. Okay. Example 2, if I've got 2x squared y cubed to the power of 3. Okay, so for instance here, I know that each product needs to get that power. All right, so I'm going to take that power and I'm going to put it inside my bracket. Because it is a monomial, I can do this. So remember, if it's a binomial, we can't do this. Okay, so then the 2 will get 2 to the power of 3. Then x, I've got x squared. So if I do this on the side, x squared to the power of 3. So this would be 2 times 3, so it would be 6. So x to the power of 6. Then I've got y to the power of 3 to the power of 3. So that would be y 3 times 3, which would be y to the power of 9. Okay, and I ask myself, can I simplify it more? I know what 2 to the power of 3 is. That's 8. So I've got 8x to the power of 6, y to the power of 9. I want you, if you know you make this mistake often, NB, that coefficients also need power. Okay, so a lot of people make this mistake where they say, okay, from this step onwards, they say 2x6, y9. And they didn't take into account that this 2 also needs a power. Okay, let's do another example. So example 3. Okay, I've got now a constant in front of this bracket. X, y to the power of 3, z 4 to the power of 2. Now, if you're not sure if you're supposed to multiply that 3 in or do the exponents first, remember BEDMAS. Okay, so brackets, exponents, division, multiplication, addition, and subtraction. So if I look at this, brackets, you're looking at inside the bracket. Can I simplify anything inside the bracket? In this case, I can't. Then I look at E, which is exponents. So this is where I do, let me see if I can highlight something nicely. This is where I do this part first, okay? I'm going to take that away. So I do that part first. I first do the exponents, which means my 3 stays there, okay? I'm only doing the exponent. So then I need that exponent to go to each one. Okay, the power needs to go to every single one. So then it will be x to the power of 2. Then I've got y 3 to the power of 2, which would be y to the power of 6. Then the z, I've got z to the power of 4 and to the power of 2. So this would be z, 4 times 2 is 8. Okay, and now I can multiply. So this 3, because it's a monomial inside this bracket, it will just be 3x squared y 6 z 8. Okay, let's do one with a negative coefficient. So let's have a look. Okay, so this is example 4. What if we have okay, we have something like that. Okay, so remember each one of them is going to get that power of 3. So it's all 3 of them are to the power of 3. So let's first deal with my coefficient. So this will be negative 2 to the power of 3. I'm putting it in brackets because I want to keep in mind that that negative is cubed as well. Then a 2 times 3 is 6, and then b to the power of 3. Now I can simplify that negative 2. So what is negative 2 cubed? So remember, if I've got negative 2 times negative 2 times negative 2, if I go negative 2 times negative 2, I know that's going to give me a positive 4. And then I've got times negative 2. Positive times a negative gives me a negative, and 4 times 2 gives me 8. But I can just remember, and you can write this down for yourself, that if there is an odd exponent with a negative inside, then my answer will be negative. So then I've got 2 to the power of 3, which is 8, a to the power of 6, b to the power of 3. Okay, let's look at roots. So we've done powers. I want to have a look at roots. Okay, so this is square roots and cube roots of monomials. Okay, so square roots and cube roots of monomials. So if I have a look here, let's do an example. So example 1, I've got the square root, square root of x squared, y to the power of 4, and z to the power of 6. Now the exponential law that I need to remember here is that if I have a root with an exponent, then I can take that exponent inside and divide it by the root. So m over n. Okay, so for instance, I know this is a square root, so that root is 2. So what I'm going to do is I'm going to take x, 2 divide by 2. I'm going to take y, 4 divide by 2. I'm going to take z, 6 divide by 2. And now I can simplify that. So x, 2 divided by 2 is 1. Y, 4 divided by 2 is 2. And z, 6 divided by 2 is 3. Let's do another one. Okay, so another example, not sure which one we're on now. If we do square root 64 x4 y squared, okay, so we're going to square root each of those and we're going to apply our exponential laws when necessary. But remember, this, 64, this coefficient here is still a normal number. So we're still going to square root 64 normally, okay? So the square root of 64 I know is 8. Then my exponents, so x, 4 divided by 2, y, 2 divided by 2. So this will be 8x squared and y to the power of 1. Okay, so please make sure once you square root, that square root goes away, but you have to apply your laws. Let's look at some cube roots. So if I have the cube root of 64, a to the power of 3, b to the power of 9, and c to the power of 6, okay, I need to remember if I've got a, the root n, and to the power of m, then I can say m divided by n. Okay, so with the cube root, remember this number is a normal number, so we're going to cube root 64. So if I cube root 64, I'm going to get 4. Okay, so then this is equal to, so since I'm cube rooting, that cube root falls away. So it will just be 4. And then my exponents, I've got 3 divided by 3. B, 9 divided by 3. And C, 6 divided by 3. So I've divided those exponents by my root. This will be 4a to the power of 1, b to the power of 3, and c to the power of 2. Okay, last one for this video. If I've got a cube root of 64, x to the power of 12. So remember, I cube root that 64 normally, which we know is 4. And then x, it will be 12 over 3, which will be 4x to the power of 4. Okay, I hope this helps you guys, and let me know if you need any help.